Okay, 5.3, solving by elimination now, right? So we've already done graphing, and then we did substitution, and now we're learning a new way, it's elimination. Here are some steps that we could do to do elimination. And I think that some of these steps don't really make sense until you see how elimination works. So I'll pull this up back at the end of the video. So look in here. This should be 5x plus 7y, plus 7y equals negative 9, and 5x minus 2y equals plain old 9. Now what we do when we eliminate is we're going to add or subtract the two equations together. And something important is that they have to be in the same order. See how we have the x's, and then the y's, and then the equals, and then the constants. They have to be in the same order. They don't have to be in that order, but they need to be in the same order. Here, I have positive 5x on top and positive 5x on the bottom one. So I want to add or subtract these together, and I'm going to subtract these because 5 minus 5 is 0. I'm trying to eliminate a variable. So 5 minus 5 is 0x, and then 7y minus negative 2y, well, that would be plus 2y, 7, 8, 9. And then negative 9 minus 9 would be negative 18. Now I can divide both sides by 9, and I have y equals negative 2. That's all of the steps that are new to this. We subtracted them apart, or well, subtracted them together, subtracted them apart, however you want to say that, so that the 5's and the x's cancel, and then we were able to get y equals negative 2. Now, just like last time, we need to plug back in to get an x equals, and it doesn't really matter which one we plug into. I'm going to choose the bottom one. I think it would be slightly easier. So this would be 5x minus 2 times negative 2 equals 9. So 5x plus 4 equals 9. 5x equals 5, and x equals 1. Now, as always, I write this as a point. It would be the point 1, negative 2. And that's my answer. Scrolling down, example 10. This is going to be 12x minus 5y equals 31, and 4x plus 9y equals 21. Now here we still want to use elimination, but we're going to have to do another step in between. None of these variables, they don't have the same coefficient, right? We've got 12 and 4 for the x. We've got negative 5 and 9 for the y. So what we're going to want to do is we're going to want to multiply one of these equations, or divide, but in this case it's going to be multiply, so that they do line up, so that they're the same number. So we have to make the decision. Would it be easier to make 12 and 4 into the same number, or negative 5 and 9? I think it would be easier to turn a 4 into a 12. So I'm going to do that. I'm going to turn this 4 into a 12, and to do that I'd multiply by 3. Now whenever I multiply by 3, I have to multiply each piece of the equation by 3. So I'm going to start off by just copying down that top one. That's 12x minus 5y equals 31. And then for the bottom one, I'm going to multiply each piece by 3. So this would be 12x plus 27y equals 63. Now I can subtract them, and my x's would eliminate. So 12 minus 12 is 0. Negative 5 minus 27 would be, what would that be? Negative 30. Let me type that in just to make sure. Negative 32. And then 31 minus 63 is negative 32 again. Dividing by negative 2, I'd have y equals 1. Now I need to plug back into an original equation to get my x. I think it'd be slightly easier to plug into the bottom one, so I'm going to do that. I would have 4x plus 9 times 1 equals 21. So 4x plus 9 equals 21. 4x equals 12, and x equals 3. To finish, I write this as a point. It would be the point 3, 1. All right, scrolling down again. This one here, this is going to be an x minus 3y equals 2, and negative x plus 2y equals negative 3. This one's nice and already set up for us. I have a positive 1x and a negative 1x. So those will eliminate nicely for me. I'm going to just add those together. 1 plus negative 1 is 0. Negative 3 plus 2 is negative 1. 2 plus negative 3 is negative 1 again. So y equals 1 after I divide by negative 1 there. I'm going to plug back into the top one. So I would have, what would that be? X minus 3 times 1 equals 2. So x minus 3 equals 2, and x equals 5. Writing my final answer as a point, it would be 5, 1. Example 12. Let me see what this one should be. This should be 4x minus 3y equals 8, and 5x minus 2y equals negative 11. Now this one, we notice right away that none of the variables have the same coefficients. So we're going to have to decide what could we change them into. In there, well here, 4 and 5. There's no way to, in one step, turn the 4 into a 5. I could turn them both into a 20, right? Yeah, I could turn them both into a 20, but I couldn't turn them both into a 4 or a 5. Similarly, negative 3 and negative 2. I couldn't turn both of those into a negative 3 or negative 2, but I could turn them both into like a 6 or a negative 6. So we get to make the decision. Are we going to deal with the yellows or the blues? I'm going to deal with the blues because to me, I could turn those both into a 6. So I'm going to do that. The top one would need to multiply by a 2 to turn into a 6. And the bottom one would need to multiply into a 3 to turn into a 6. So the top would turn into 8x minus 6y equals 16. And I'm going to do a little bit of a trick here. I'm going to multiply by negative 3 on the bottom. I'll tell you about that whenever I'm done with this. Negative 3 times 5 would be negative 15x. Negative 3 times negative 2 would be positive 6y. And then this would be a positive 33. Now the reason that I multiplied by that negative would be so that these two are opposite signs so that I could just add these together. I think adding the equations is just a little bit easier than subtracting them. So whenever I add them up, I'd have 8 minus 15 would be negative 7x, and then my y's go away, and I'd have 16 plus 33 would give me 49. Dividing by negative 7, x should be negative 7. Now I need to plug back in to get y. I'll plug into the top one here. So that should give me 4 times negative 7 minus 3y equals 8. Negative 28 minus 3y equals 8. If I add 28 over, I would have negative 3y equals 32, right? No, 36. And then dividing by negative 3, y would be, what would that be? 36 divided by negative 3? Negative 12, yeah, negative 12. There we are, and we can write this as a point. We'd have negative 7, comma, negative 12. All right, so that's how we do elimination. Let's go back up and look at the steps. So step 1, it says multiply, if necessary, one or both of the equations by a constant, just by a number, so that at least one pair of like terms has the same or opposite coefficients, right? And that's what we did on all of these whenever we would multiply by a number. Like in this one, we multiplied by a 3. Look at example 2. Add or subtract the equations to eliminate one of the variables, right? That's what we did. You could see that happening right there. That's whenever we added them together. And then solve the resulting equation. Well, we know how to solve something. And then we substituted back in to get the other variable. All right, so if you need that, if you need those steps, write those down. Make sure that you have these problems written down. Make sure you have number 12 written down. That one's probably the hardest one. All right, that's all.